Hey, I'm a big fan of space and figured I'd put a video together which I call The Greatest Voyage. The subtitle of my video is Cosmic Distance, Exoplanets, and Starships. So buckle up, because here we go. So our journey kind of begins at our home planet Earth, which is 4.5 billion years old. It's located in the wider solar system, and we have a sentient, hopefully intelligent population of 7.2 billion people. In terms of the neighborhood, we have 8 planets, with the solar system at large being part of a wider Milky Way. And to the best of our knowledge, the sentient population remains steady. One thing I do want to point out is like the image you'd see of the Earth would be something like that just popped up on the screen, but in comparative size, that's Earth right there. It's just a speck in the solar system, and the solar system is a speck in the wider galaxy, as you'll notice soon, and the galaxy is just a speck in the wider universe. But look at the size of Earth, man. Something Carl Sagan used to call pale blue dot. If you haven't seen that video, I would encourage you to go and check it out on YouTube right after you finish watching this video. And if I sound different, that's because I have a cold, not because I'm trying to sound cool. And that's only if I'm making the assumption you've seen some of my older or other videos. Anyways, let's move on. And here we go with the golden ratio. I think I overdid it with the golden ratio, but I'm not gonna redo the slides. So if you kind of zoom out a little bit, the model of the solar system would look something like this. You obviously have all the planets. You have the something we call the asteroid belt between Mars and Jupiter, and you also have this is largely inner solar system we're talking about. Then the outer solar system has a bunch of other things. It also has the Kuiper belt, which some of the other outer solar system planets within it. And again, if we zoom out a little bit, then we would notice that our sun is just one of the many in the interstellar neighborhood. The closest to our sun is something called Alpha Centauri. It's around 4.37 light years away, which roughly translates into 25.6 trillion miles. So yeah, even though it may be the closest to our solar system, it's still pretty far. All right. So the Milky Way is really our part. Um, we call our galaxy where our solar system is located as the Milky Way. And if you're out in the country or somewhere where there isn't a lot of light pollution, then you can kind of get a glimpse of what the Milky Way looks like in those locations. When you look up at the night sky, you kind of only see a glimpse of one of the arms of the Milky Way, and the image on the right is a more accurate, I guess, depiction of what the Milky Way would look like if you kind of looked it outside in. And the interesting thing is the interstellar neighborhood would just be a tiny speck, like I said, in the wider Milky Way. And we're actually like situated somewhere along, like where that arrow is pointing. We're not in the middle of the galaxy or out on the fringe. We're like somewhere. I guess it's kind of like sort of middle. Oh, that's my attempt at some humor. I guess it's pretty bad. I know. All right. Yeah, golden ratio. So here would be an artist's kind of representation, or how an artist would conceive of the Milky Way to be. I wouldn't be surprised if it's too far off from what the Milky Way actually looks like with the spectral astronomy and whatnot. The interesting thing to note here is that our solar system, along with the other galactic neighborhood, uh, solar neighborhood, is part of something called the Orion Cygnus Arm. Um, and the galaxy itself is part of a wider cluster known as the Virgo cluster. But the interesting thing coming back to the solar system is that it takes our sun 200 million years or more to go around the galaxy. I mean, that I just found out about that a couple of days ago, and I mean, dude, just stop and think about that for a second. entire species can evolve or get wiped out. The dinosaurs got wiped out 200 million years ago, so by the time it took Earth to go around, sorry, the solar system to go around the universe, we evolved from, I don't even know what, marsupials or something. That's like unreal. 200 million years compared to 365 years for Earth to go around the sun. Mind boggling. Alright, so if you did zoom out, then the observable universe would kind of sort of look like this. The arrow that just popped up is where our Milky Way would be in the Virgo supercluster. The interesting thing to note is that, and I'm going to share the numbers or a brief glimpse into the numbers in a bit, but there's like hundreds of billions of galaxies, potentially trillions upon trillions of planets. I don't even know how many atoms. A lot. Like, just think about how many people in the world itself alone, how many plants, animals, whatnot. And you multiply that by some astronomical figure. I mean, think about how big the universe is based on just some of the slides you've seen so far. But the really interesting thing is, all that exists and is observable in the universe is only 4% of the universe. All the stars, planets, galaxies, everything within them, inanimate, living, something else, it's only 4%. It's like the minority in the minority. 96% is dark energy and dark matter, and we don't know a whole lot about dark energy and dark matter. I had a chat with an astrophysicist about it last year, and so much to learn, man. So much to uncover. Just enough 4%, and then that 96%. All right, let's move on. So there's approximately 170 to 200 billion galaxies in the universe, and our Milky Way contains anywhere from 200 to 400 billion stars and at least 100 billion planets. The numbers kind of fluctuate depending on who you look at. Sometimes NASA says it's more, sometimes it's less. Obviously, their estimates are updated based on more data that they uncover. This can't just make these numbers up. But yeah, that's roughly about the range for both the galaxies and then the number of star systems within at least our Milky Way at the very least. So before we move on, let's just do a quick recap. So we have Earth, part of a larger solar system. It kind of looks like this. Then you have the solar interstellar neighborhood, and then the galaxy itself, and then finally the observable universe. So next I want to talk a little bit about exoplanets, and these are basically planets that orbit a star system other than our sun. So far we have identified 2,000 of these, and we've been looking since 1988. And artists would conceive of exoplanets to look something like this. I wouldn't be surprised if some of these planets actually look like that. And just gotta wait for astronomy and astrophysics to get better and better. So, like I said, 2,000 identified so far. 2014 was monumental. Like, look at the graph. Like 900 identified in that year alone. I don't know how many we identified last year, but it's only going to go up. The numbers are going to go up because we are launching more telescopes, more advanced telescopes in the sky, in the orbit. This one's called James Webb. It's going to be operational in 2018. Kepler so far has done a lot of good work. Yeah, man. Like, think about the possibilities. How much is there to discover? Trillions and trillions of planets waiting to be discovered. Like, for us to find out their type, topology, composition. The whole intent here is to really find another Earth. That is what NASA's trying to do. That's what a lot of other space agencies are trying to do. And with the findings of the 2,000 or so exoplanets, we are barely scraping the surface. So next, we talk about the circumstellar habitable zone, also known as the Goldilocks zone. It's a region around the star system with planetary mass objects, which have sufficient amount of atmospheric pressure for them to hold liquid water. So basically, planets around the galaxy that can support oceans or lakes. So again, Kepler has been very successful. Whatever model Kepler uses is mostly automated. You find exoplanets, and then within those exoplanets, you find the ones that kind of sit in a nice Goldilocks zone. Something that can turn into another Earth, potentially another Earth. It's just a snapshot of the data gathered through Kepler. And it's just a snapshot from 2011. It's definitely more planets to be added there as of last year or the year before. All right, so as a species, one of our immediate goals is, like I said, to find another Earth. And you just got to keep mapping more exoplanets and kind of categorizing them appropriately. We're making good progress here, as you've noticed. And just to kind of shed a bit more light on it, these are some of the news items from the past couple of months. Actually, most of these news items are from the past 40 days. There's just one item from July that made me want to categorize it as the past couple of months. But if you're really interested, just tweak your Google Alerts filter to something like exoplanets or maybe Goldilocks zone, and there's like some kind of news item coming up every week. All right, so the question then becomes, okay, we've made advances in astronomy and a couple other sciences. We have found, hypothetically speaking, a couple of planets in the habitable zone. How do we get there? That's a good question. It's a really good question. Now, the thing to consider is, considering the existing state technology, the journey to another planetary system or sun or orbit, planets orbiting a sun would probably be a one-way journey, considering the enormous distances between our solar system and the other solar system. And depending on when we decide to launch such a mission and what kind of technologies exist at the time, there really are a bunch of different ways that will be available in the future. And there are a bunch of different ways by which this could be achieved in the next couple of decades, if it were to be achieved. So, you'd probably want to, I don't know, like it's all contingent on, again, the kind of technology that is mature, but probably want to start with something closer to us. Something in the 4 to 6 or maybe higher light year category. By all estimates, again, using existing state technology, it's going to take us anywhere from 130 years plus to get to any one of these planetary bodies. That's just a casual reminder that we're talking long distance here. Alrighty, so let's talk about starships. So right off the bat, something like a liquid rocket engine propellant machine or rocket ship is going to be out of the question because the distances are huge, and I don't think we're going to have the payload or capacity to be able to carry that much fuel with us. So that kind of leaves us with something like a nuclear propulsion system. Here, I came across a project called Project Orion. Just like, I'm going to share the numbers, but this is pretty promising. Some drawbacks to kind of actually manufacturing this on the surface and then firing it up in orbit. I think there's the potential of some kind of a containment or something. And if you can somehow figure out a way to manufacture this puppy in orbit, then we're in business. I got a couple ideas here. There's a combination of different techniques that can be used to manufacture something like this in orbit, which I'm not going to discuss in this video, but super promising. Like, when you look at the numbers, I mean, I kind of listened to one of the guys who was on the original project team a couple of decades ago. His name is Freeman Dyson. He's a pretty famous scientist. If you're into this kind of stuff, you may know of him. I've heard of him. Yeah, I remember Mr. Dyson, kind of talking about putting entire tennis courts and even like apartment buildings into Orion-sized ships, and then setting sail for places like Mars and Jupiter. And that's just kind of unreal, the kind of payloads that they were talking about. So I think Orion, overall, in a nutshell, is a very promising candidate for interstellar distances or voyages. Anything beyond that is like mostly stuff of science fiction in terms of wormholes, and it's like looks good in like the movie Interstellar. I don't think it's going to be that feasible, at least for the next 20, 30 years. I don't think it's possible. It's like different schools of thought on how much energy is required to power something like this. Some say there is a lot required, some say there isn't, but no matter how you slice and dice it, I don't think that something like this is going to be possible in the next couple of decades. I don't think so. It's going to be interesting to be proven wrong here. Alrighty, so whatever solution we choose, we need a starship that is resilient. The design is really well thought out because you're talking about a multi-generation ship. You just can't just build a giant plunk of iron or steel or whatever and say, there you go. And you just gotta figure out all the intricacies, all the it's like all the different things beyond just the manufacture of the device, like life support systems, ways of growing food and whatnot. Talk about some of those things in the next slide. But yeah, the uh, design is how the ship works. It has to be really well thought out, and most of the operations have to be automated for it to be functional. Um, it's like we're talking about a very long journey. So you're literally talking about something that can, like a mini version of Earth that can sustain itself for that long duration. And um, yeah, it's a lot of work. That is definitely a lot of work. A lot of interesting work. All right, so what do we have next? What happened to my slides? All right, so in order to be able to build the starships, we I think the need to build something like a 100-year starship is going to be felt. The need is going to be felt more acutely as more time passes by. Um, my sense is that as more and more of the solar system gets colonized, and we kind of max out on the colonies, and I don't know, like even if we come up with artificial constructs, like somewhere between maxing out and kind of hitting that limit, we'd definitely start thinking of building 100-year starships by then. So I mean, if this is a couple hundred years out, then technology would have matured substantially in order to be able to power some of these voyages. If, barring some reason, we have to do this in the next couple of decades, I think some of the technologies would still be ready and mature. Like estimates suggest technologies like nanotechnology are going to be functional within the next 15, 20 years. So no matter how you slice and dice it, there isn't anything stopping us from creating 100-year starships in the mid to long run. Mid to long run in this case is anywhere from 20 to 200 years. So the question then becomes is if building the ships alone is not enough, then what else do we need? That's a good question. It's really especially a good question if we're talking about sending sentient beings, as in flesh and blood, to embark on such a journey. I think what's going to be needed here, amongst other things, is advanced energy systems, to state the obvious, automated systems for growing and storing food. So you're talking about growing food in the air or in water, mostly in air. We need advanced hibernation units. Doesn't matter if it's a multi-generation ship. We need something for these long journeys. Um, hibernation for like months, perhaps years on end. Obviously, we need advanced propulsion systems. We kind of get a glimpse of that with Orion and its capacity to be able to carry huge payloads. Now, we've got another slide where I'll talk about some of these numbers. We need advanced 3D printing for manufacturing and a bunch of other things. Again, estimates suggest nanotechnology to be functional within the next 20 years. So pretty hopeful about that. Super hopeful, very excited to see. I'm a huge fan of Eric Drexler, by the way. Uh, Whenever I get a chance, check him out on YouTube. I haven't read Engines of Creation, but it's definitely on my Amazon reading list. It's not available in my local library. I'm kind of poor right now, so. Okay, I think I've spoken too much about nanotechnology. What else is going to be needed? So, I think those were like the base pillars. In terms of the design, which I was referring to earlier on, this growth that I've just referred to is going to be supported by the following at the very least. So, artificial intelligence as an umbrella term with machine vision and machine learning as a subset of it is going to be very important. Most of the operations, if not the entire operation of the ship is going to be automated. The manning, the life support system, growing the food, sustenance, perhaps even taking care of the sentient beings, all the way from child rearing to evolution, perhaps, and beyond, like teaching skills and um, like mapping out what kind of um, once you kind of get to or start getting near the surface, you launch probes and you find out type composites, blah blah blah. Can't say the word. Composition of the actual planet, composition of the actual planet. Jeez, I must be getting tired. Then kind of modify the algorithms to be able to figure out what kind of life form is going to be needed on such a planet. Modify the life form accordingly. So that's what artificial intelligence kind of works with, in combination with genomics and perhaps like CRISPR. Um, so yeah, that's going to be just a glimpse of how AI systems are going to be used. Robotics, to state the obvious, a whole bunch of operations on the ship, on the probes, on whatnot. Local manufacturing if it needs to happen on the surface. Going to use robotics mostly, a whole bunch of variety of different diverse formats, including mobile robotics for a whole bunch of region, transportation amongst them. Genomics, to state the obvious, I've just kind of shared a glimpse of it, also includes the ability to be able to grow food that's genetically modified for different environments, including on the ship. Crops that are resilient in some respects, even modifying the genome of the life forms themselves, like I said, for making life conducive for other planets. And that's again just a glimpse into genomics. Synthetic biology, man, the promise is huge. So I read a book here, I forget the name. I think it's called Regenesis. Yeah, that's the name. So one of the things they mentioned in this book is it said one of the many examples of synthetic biology is probably talking too much on this line, but like imagine putting a seed on the ground and the seed, instead of turning into a tree, turns into a house. So when I first read this, I was like, I wanted to make sure I wasn't hallucinating. So I went on Quora.com and I double checked to see if what was written was actually true. And turns out this is just one of the many ways, one of the many promises of synthetic biology. Like you can do a lot of stuff with the science. You can create synthetic life forms other than what I just shared that could produce oxygen on another planet, like sucking up the carbon dioxide and exhaling oxygen like diatoms. You could make organisms that could inhale the carbon dioxide and turn it into fuel, as in fossil fuel that we could use. And these are just three of the many, many, many examples of what synthetic biology can power. Super exciting science. Nanotechnology, like I've already mentioned, there's nothing you cannot not do with nanotechnology. As long as you can arrange the atoms in a specific format, then that's really what chemistry is. So it's really using physics in order to be able to make anything, including chemical structures. And once you can do that, you can literally make anything in the future. You don't have to stitch proteins together in order to be able to make food or manufacture using the traditional cycle. You just make it in a replicator in a Star Trek kind of fashion in a future sense. It's like still 15, 20 years out. Neurosciences, been giving this a lot of thought. But one of the things I was thinking, I was like, if you're going on a longer journey, then you need some kind of mechanism in order to be able to back up your consciousness at the very least. And another way I was thinking was you could have advanced brain machine interfaces. So obviously the machine to be able to operate a ship like that is going to be pretty complex. And that's one of the areas where neuroscience, two of the areas where neuroscience could help. I've already kind of touched base on advanced energy systems, and obviously space science is going to need evolution or um, development in this area in a variety of different ways. Okay, I think that's probably a slide where I talk the most, but let's move on. So to come back to Project Orion and just look at the numbers like directly from their Wikipedia page. It's like unbelievable the amount of payload that these machines can carry. And according to the estimates on Wikipedia, we can get to Alpha Centauri within 133 years. That's pretty significant. Alrighty, so what's next? I think it kind of depends on the time frame what you're looking at, but we're well on our path towards developing some of the things I've mentioned. In terms of the power, you could also use something like contained fusion or antimatter drives in a near future scenario. I think maybe antimatter drive is a couple of decades out, but Lockheed's been doing some really interesting work with fusion. So they either have, I think, a breakthrough or they're pretty close to one. I think it's either or. I forget which one. I should know this. But yeah, contained fusion would be something pretty cool. And you kind of replace, like, I mean, dude, fusion is like clean energy. It's awesome. All right. So I want to talk about DARPA's 100-year Starship program. Something I found out about, I don't know when, but it's pretty interesting. They're not thinking of building an entire ship, but just to kind of work on the detailed plan that's going to be required in order to be able to power a 100-year journey through interstellar space. I mean, anyone who knows anything about DARPA is like, these guys know innovation and these guys know science, and it's like most of the cutting edge stuff comes from there, all the way from the internet to robotics, like Boston Robotics and whatnot. It's like part of Google now, but like so many cool inventions. I mean, that's pretty exciting that DARPA is focusing on longer term projects and not just like short term 1 to 5 year projects. It's like super exciting to see them again focus on a project like this. So before I kind of conclude the slides, I just want to say if you're, like you're in your teens or in your 20s and you happen to have stumbled across this video, I want you to start thinking about some of the ways that interstellar travel is going to happen in the near future, because you're the kind of guys and girls who are going to be designing the systems and the subsystems and the various aspects of the construct in order to be able to power such voyages. So again, whether these happen in person or through some remote means, I think this most probably going to happen with real humans. Just I think, I mean, depends on how advances in AI and what kind of advances in neuroscience we make, or the creation of a mind, recreation of a mind. But anyway, so most probably you guys are going to be the ones creating these systems. It's important to kind of think, project, and anticipate what's going to be required from a near future point of view in order to be able to power such, again, journeys. There's a lot of opportunity. I think most of the opportunities, I've kind of identified 18 areas. 8 of them are major areas, and space is definitely one of them. And our expansion through space is going to push so many other technologies and so much opportunity here that's unimaginable. And you kind of take a look at some of the slides in order to be able to have an appreciation of the scale and magnitude and like how diverse the universe is and how much more there is to go and travel. Like we are just a speck in an ocean. So with that, I conclude my slides. if I may share something personal at this point, there has not been a day when I haven't looked up at the night sky and be amazed and wowed by the beauty and wonder of the universe. And I always have this thing where I think about what worlds may lie beyond our solar system, and what kind of planets may exist, what lands may exist on those planets, and different structures. Perhaps there's life on some of these planets, and perhaps there's intelligent life on uh, some of the other parts of the galaxy or the universe at large. There's so many questions related to space, and how intricately everything seems to be tied with it. There's this like order and structure in the general um, when it comes to the general formation of the galaxies. And so there's so much beauty in physics and laws of physics, and you just gotta marvel at the beauty of the universe at large. All right, I'm speaking too much at this point. I just want to say, if you did watch the whole thing, thank you so much. Please do share this video with your friends, family members. Show it to your kids if you have any. I make a point of always sharing news and items related to science and space in general with everyone in my family. So, and if you get a chance, also click on the share button through YouTube and share it through the various social media channels. Thank you so much. Have a nice day.